cells are ribosomes, which make protein. But now, hidden among them, is an enemy factory hard at work. When the cell has made enough copies of the virus, it dies, and thousands of new viruses leave in search of new cells to invade. This is what happens when we catch a cold, and far worse diseases. A cell nucleus is seen here in the middle. Surrounding it are viruses. The smaller mitochondria are still working away, protected inside the cell membrane. But their fate is already sealed. Using a unique photographic process, we can now catch the viruses in the act of entering the cell. About 100 of them are grouped on the cell's surface. Then suddenly, as if on a given signal, they force their way through the cell membrane. A few days later, they leave in the thousands, just as these mast cells empty their contents. Our most important weapons against viruses are the lymphocytes. They bombard the enemy with antibodies, small molecules made of protein. The antibodies are visible as a corona surrounding the cell. But as effective as these lymphocytes are, they are no match for the viral disease we call AIDS, the most feared plague of our time. This is HIV, the virus that causes AIDS. HIV uses lymphocytes themselves as host cells to make copies of itself. So the cell we count on to kill the enemy becomes, instead, its victim. The virus spreads, and we die. This parasite causes another deadly threat, snail fever. All it takes is one misstep in a water hole. The parasite lives in the stomach of a snail. It waits patiently for another host animal to pass by. The parasite larvae then leave for greener pastures, penetrating the skin of the foot. Inside the bloodstream, the larvae mature into worms. Stuck to the walls of arteries and veins, they feed on our blood. Here you can see the parasite's mouth sucking up blood cells. The female parasite is thinner than the male and lives attached to his body. Their eggs are then carried away by the bloodstream. They leave our body in urine, returning to the water and other snails, completing the cycle. Another parasite lives in a mosquito and causes malaria, a chronic and often fatal disease. When the mosquito bites, the parasite is injected through the skin and into the bloodstream. It lives among our red blood cells, feeding upon them and reproducing in them. The blood cells die, and the young parasites pour out to be sucked up by other mosquitoes, which then bite other victims, spreading the disease further. Parasites affect animals and humans alike. They do more damage to both than any other microscopic enemy. This fight for survival binds all creatures together: animals, humans, microorganisms. It's just that some battles are more visible. The struggle to eat or be eaten is universal, timeless, inescapable. But when it comes to the unknown world, we humans seldom pay attention if we ourselves are not at risk. And yet all we have to do is take a closer look. Beneath our very noses, we can find a myriad of creatures, like these scale bugs, who can live their lives in a flower pot on a single plant. Every inch of this greenhouse jungle is inhabited. And the same kind of drama played out on the African savanna is found here, even if the protagonists are humbler. These aphids are sucking the sap from a leaf. Here, an offspring climbs on the back of one with its siphon-like tubes. That's quite handy for these ants, who treat the aphids like cattle, herding them from pasture to pasture. The aphids are then milked of their sap. But this ladybug wants steak, not milk. It feasts upon the grazing aphids. And this red predator mite isn't just hitching a ride. Another aphid is the target of this hover